Okay, we're gonna keep going here. My phone just went kaput for a minute. Okay, so effective nuclear charge is determined by proton number and by something called shielding electrons. So we have two factors, proton number and shielding electrons. So I'm just gonna draw a picture over here that kind of talks a little bit about each of these things. So I'm gonna draw a line that kind of separates this. So let's say that we're looking at a substance like nitrogen, and we want to look at like a layering diagram or a Bohr model of nitrogen. So we have 7 protons, and the electron layering, if we're doing it like good old Bohr, we would have 2 electrons on the inside and 5 electrons on the outside. So these inner electrons right here, these 2 electrons in the middle, sorry about the shadow, the inner electrons, they shield the outer electrons from the nucleus. So what they're doing basically is interrupting the attractive force. Between the nucleus and the outer electrons. Okay, and so we would look at this and go, all right, well, there are 2 shielding electrons and 5 valence electrons. Remembering that valence electrons are the outermost electrons. So we want to remember that shielding electrons are the non-valence electrons, right? Gonna put that in parentheses there. And then, so we could look at this and say, well, there's 2 electrons shielding and 5 valence electrons, versus if we looked at something like fluorine, and fluorine has 9 protons, and so our shielding electrons, we would have 2 and then 7 valence electrons. And so we want to recognize that the shielding in both of these elements is the same. They both have 2 electrons shielding, and there are 5 valence electrons here and 7 in the fluorine. So we would recognize that because fluorine has 9 protons and 2 shielding electrons, that these electrons in fluorine would feel a greater effective nuclear charge than the nitrogen's electrons. So we could make a statement that the fluorine will have a greater effective nuclear charge because they have the same amount of shielding electrons but more protons. So these guys, these 7 electrons are going to be more attracted to this nucleus than these 5 electrons will be to this nucleus, because the shielding electrons are the same versus 7 protons of attraction and then 9 protons of attraction. So these 7 valence electrons, again, are going to have they're going to experience a greater effective nuclear charge than these 5 electrons here. So we'll cut, oops, sorry, that went off the page there. We will stop there with that idea and move on here in a minute. So we'll be back with part 2. Thanks.